Okay, we're going to look at Math 31, Section 1.6, Dividing Whole Numbers. This first section, Section A, we're supposed to find the quotient, is really teaching you the language of division here in symbols. There are two styles. One is the old style division symbol, and the other is the fraction bar, and both mean division. So, for instance, example D is 48 divided by 6. Okay, let's see how well you know your times tables. 28 divided by 7 gives 4. And we know that since 4 times 7 is 28. 48, I'm going to skip to example D real quick here. 48 divided by 6 is 8. That's because 8 times 6 is 48. Okay, examples B and C are kind of exceptions. And I'm going to start with example C. 0 divided by 12 is actually 0. But if you try to go the other way, 6 divided by 0 on example B, dividing by 0 is undefined. In other words, you can't actually do it. So we just write undefined. Now, it's hard to keep these two, examples B and C, separate from each other. When is it undefined and when do you actually get 0? So I have a little device that I've learned. This is not original to me. But if you have a 0 on top, let me do this in another ink color. If you have a 0 on top, like problem C here, that's okay. You actually get an answer. But if you have a 0 on the bottom, no way. Doesn't work. Okay, so I hope that does it for you on those 4 problems. Now, in this next section here, we're going to be looking at long division. And you might see that for efficiency's sake, I've penciled in the answers here. But I'm going to show you in step-by-step how we get these answers. On example E, we're going to divide 3,496 by 8. And so we look at this problem as 8 divided into 34 to start with. And since 8 goes 4 times into 34, 4 times 8 is 32. Doesn't quite go in there. You subtract and you find out there would have been a remainder of 2 there. Now you bring down the next digit and you do this process over and over again. So how many 8s go into 29 would be the next question. And 8 times 3 is 24. That's probably our answer. But 8 times 4 is too big. That'd be 32. So we'll go 3 times 8 to get 24. And subtracting gives 5. And here comes a 6 joining the fight. So the question now becomes how many 8s go into 56? And if you know your multiplication tables, you know that 7 times 8 is exactly 56. So here's a problem where there's no remainder, and our quotient is 437. Okay, it's a little more difficult on example F because our divisor out here on the outside is 2 digits. Now you want to kind of estimate that. When you're trying to figure out what to put up top, you think of that 53 as closer to 50 than 60. So you're going to round it. And because it's closer to 50, I'm just going to think of it as a 5. Okay, so how many 53s go into 32? Not enough. I have to go further over. So how many 53s go into 328? Well, how many 5s go into 32 is how you think of that. And we'll put a 6 there. 6 times 3 is 18. 6 times 5 is 30 with 1 added. And when you subtract here, you get 8. You get 10. Here comes a 6 joining the effort. And now the question is how many 53s, let me get rid of that old carry mark here. How many 53s go into 106? Well, how many 5s go into 10 would be a good place to start. So 2 times 3 would be 6. 2 times 5 is 10. That worked out just perfect. So this is a quotient of 62 with no remainder. Okay, our luck is going to run out of us on some of these. We're going to get some remainders here, and I'll show you how to handle that. Okay, This is a series of problems where you have division. It's just couched in words instead. For instance, on example G down here, it says find the quotient of 174 and 8. So I have it set up here. And we'll start by asking how many 8s go into 17. 2 times 8 is 16 is the most we can get out of that. And subtracting gives 1. Bring down the 4. And now you're asking how many 8s go into 14. Only 1. 1 times 8 is 8. And we're going to have a remainder of 6 here. So there's a couple choices here. Probably the best way, although not the easiest way, is to put a decimal there and put a bunch of zeros and keep bringing them down until you'd put a decimal there also. And you'd keep dividing until you get a repeating pattern or a terminating pattern. I'm going to let you get away with in this section, just put remainder 6. And excuse me. You'll be done with it at that point. Okay, here's another example. If a fishing company catches 358,500 pounds of fish over almost 2 months, 62 days, how many fish were caught each day on average? Okay, so we're really just dividing that large number by 62. And you want to think of that 62 in stages. It's closer to 60, and then you ignore the 0 when you're estimating, so think of 6. 62 doesn't go into 34. We're going to have to go all the way over to the 348. And how many 62s into 348 would be similar to how many 6s go into 34? So we'll go 5 and see where that leads us. 5 times 2 is 10. We'll get a carry here. 5 times 6 is 30 with 1 more added. And we'll be subtracting that value from 348 and bringing down the 5 from the next column. Okay, now we're asking how many 62s go into 385. Well, that's related to how many 6s go into 38. And I think we can get 6 out of it. So 6 times 2, let me get rid of the old carry mark up there first. 6 times 2 is 12. 6 times 6 is 36 with 1 added. And we'll be subtracting here. 13. And here comes the next 0. So now how many 62s go into 130? How many 6s go into 13 is a related estimate. So 2 times, I think. 2 times 2 is 4. No carry. I like to put a 0 there anyways. And 2 times 6 is 12 with 0 added. Subtracting here gives us 6, and here comes the last 0 into the fray. And so we're asking how many 62s fit in 60, and the answer is none. So we're going to put a 0 there. 0 times 62 is 0, and we end up with a remainder of 60 is what happens here. Okay. Last set of problems here, and this has to do with averages. To average numbers, you add them all up first, and then divide by however many numbers you added. So, for instance, here we've got 6 numbers. These represent the number of customers coming in Monday through Saturday in a little craft shop. So we'll start by adding these numbers. 23 plus 18 plus 35 plus 36 plus 70 and 88. And find out how many customers there were. So 3 and 8 is 11. 11 and 5 is 16. 16 and 6 is 22. 22 and 0 and then 8. We end up with 30 in that first column. Carry the tens digit. So now you have 5, 6, 6 and 3 is 9, 9 and 3 is 12, 12 and 7 is 19, 19 and 8 is 27. So now I have 270 customers for the whole week, and I'm going to divide it evenly among the 6 days that are represented here. And we'll start with 6 times 4 is 24, which gives us a remainder of 3 for that stage. Here comes a 0 placeholder coming down. And then 5 times 6 is exactly 30. So we have no remainder in this example. And that tells us that we had an average of 45 customers per day during the Monday through Saturday period at this little craft shop. Okay, I hope these examples are instructive and help you with your 1.6 homework.